All right, a little bit of a shorter lesson today as we have 12:30 dismissals all this week, so we only have a half hour to get as much review in as we can. But before we get to the review, I want to go over the homework that you had on Friday, page 293 in your textbooks. You did numbers 6, 11, and 12, and then also on the next page, page 294, I did the 13 through 16 there in the review section. Good. So page 293 is where we will be. That rhymes. Did you see that? No. That's where we're going to be. It's on page 293. I'll stick to teaching, okay. That's it, just 7 problems. It was a nice, short little homework assignment, wasn't it, Brecken? Yeah. All right, so on page 293, number 6, we had 7 being divided by the square root of 3 minus 2. And obviously, this is a fraction. And in our fraction, we look specifically at class the denominator, and we see something that we just can't, no, it cannot be. We cannot have this. Maddie? A radical. We cannot have radicals in denominators. But this is not just an ordinary radical denominator. This is a 2-term radical denominator. For a 2-term radical denominator, we got to do something very specific here, Brecken. Of the denominator. And of course, what we do to the bottom, we have to do to the top. So we won't just multiply the denominator, although that's really, the goal is really more about the denominator. The numerator is just whatever. And what do we mean when we say the conjugate? What would be the conjugate in this case, Brecken? Good. Basically the same thing you already had, but change the sign so that class we are artificially creating a sum and difference. There we go, Maddie. And of course, class, when we multiply a sum and difference, we get a difference of squares. Thank you, Brecken. When we do what 3 things, class? Square the first, square the last, put a minus sign between them. Don't say multiply and double, no. Square the first, square the last, put a minus sign between them. And so Noah, when we square the first?
3.
And when we square the last?
-2.
What's 2 squared? Was there a square root over the 2? There was a square root over the 2. I'm sorry, I miscopied it. All right, so the way I had it, it would have been a 4. But you're right, the way the book had it was a square root of 2. So if we square the last, we get 2. And then we put our negative sign between. Of course, we know 3 minus 2 is 1. And so anything over 1 is itself. So really, we're just going to kind of forget about the numerator, the denominator there. The numerator, we just have to do what, Maddie? To get... There we go. Of course, all over 1 just gives us this final answer, or you could just forget all about the denominator, just circle the numerator. How many have that answer for number 6? On number 11, we had a 3 minus the square root of 5 over a 2 plus the square root of 5. And Noah, let's start with you this time. Actually, what do we want to do first? Same thing we do every night. Think you try to take over the world. The same thing we do every time. We multiply top and bottom by the conjugate, which is
2 minus the square root of 5.
Good. You could say 2 negative square root of 5. That's fine. 2 minus the square root of 5. Either way we want to look at it. And of course, in the bottom, that means we have another sum and difference, which means we're going to get another difference of squares, which means we need to, class, square the first, square the last, put a minus sign between them. Maddie, what do we get? In the denominator, we always, the easy part first, Good, 4 negative 5, which becomes negative 1. Now, the fact that there's a 1 means we really don't care, but the fact that we have a negative 1 bracket means we're going to have to do what? Yeah, we have to move that negative out to the front here in just a little bit. But for now, let's go ahead and go to the numerator. That's where Maddie wanted to go, but Brecken's going to get to do this for us. Brecken, that's not a sum and difference up there. It's also not just distribution. We have 2 binomials, so we'll need to FOIL or double distribute. It's whichever way you want to look at it. It's really the same process. So FOIL or double distribute? FOIL, right, first. Outer. Good, inner. And last. positive square root of 25. Of course, we know the square root of 25 is just 5, so that we can combine the 5 and the 6 to get 11. We can combine the negative 3 squared of 5, negative 2 squared of 5. All over a negative 1, but of course we said we have to move the negative out front. So let me show you several things here, class. The negative out front only works if you still have the fraction, though. Does it make sense? You can't move a negative out front if there is no longer a fraction, right? But here's another thought. What is a fraction bar? It is a grouping symbol, correct? So we could put the negative out front and then use a different grouping symbol for the 11, negative 5 squared of 5. This would be an appropriate answer also. The other option would be just to straight up divide 11 by negative 1 to get negative 11, divide negative 5 squared of 5 by negative 1 to get positive 5 squared of 5, and now there's not a fraction anymore anyway. And you can leave your answer this way. So any of those three answers would be correct. Questions on this, especially here at the end as far as how we write the answers and why. Different ways to do it, but want to make sure we do one of the correct ways. The mistake I'll often see is students put the negative out front. They're like, wait, I don't need the 1 anymore. And so write negative, oh yeah, 11 minus 5 squared of 5. And that's not correct because the negative applies to the whole group, right? Not just the 11, and this makes it look like just the 11. All right, questions? All right, how many had one of those answers? How many did this? How many didn't FOIL correctly? Okay. You did FOIL correctly. What happened to you?
The bottom, I left it 2 and not 4.
Okay, yeah, when we square a square root, we get the radicand. When we square a normal 2, it just becomes 4. So you had negative 3 in the denominator thing. All right, then number 12, we had a 3. Negative 4 squared of 2 over 5, negative 3 squared of 2. Class, multiply top and bottom by? Conjugate, which is? Good. And I always take care of the denominator first because it's easier, and I'm lazy, and I like to do the easy part first. And what do I get in the denominator when I multiply by the conjugate, Maddie? Good, 25, negative 9 times the square root of 4. I ought to say 9 times 2, right? We square a 5, we get 25. We put our negative. We square the 3, we get 9. We square the square root of 2, we get 2. But it's not wrong to say square root of 4 as long as you realize that is 2, which times 9 gives. So my denominator is going to wind up being 25 minus 18? 7. There we go. If $25 on a gift card, spend 18 of it on something or other, how much is left on the gift card? 7. I don't know, I look at the bottom of the receipt, it says the remaining balance. Okay, you win. Look at the numerator. Once again, we got a FOIL here, Noah, first. 15. Outer. 9 times the square root of 2. I don't know why I just wrote 3. All right, the inner. And then our last. Negative 12 times the square root of 4. Here, the square root of 2 has no friends, so it just stays square root of 2. Here, the square root of 2 has no friends. Here, the square root of 2 has another friend, another square root of 2, which gives square root of 4. So we get negative 12 square root of 4, which is 2, times the negative 12 gives us. And now we can combine the 15 and the negative 24. Negative 9, keep the sign of the greater, right? And greater absolute value, I should say. And then the 9 square root of 2, negative 20 square root of 2. Negative 11 square root of 2. Now, we can't leave our answer like this. Why not, Brecken? Yeah, you can't have a negative first term. Now, if this were a positive, I'd flip-flop and put the positive before the negative. But they're both negative. What do we have to do? Which one? I I can't do that. So quick refresher, if both terms are negative, remember, we've got to factor the negative out. So it's the sign of the whole numerator, then slide it out front. So negative 9 plus 11 squared root of 2 all over 7. Should have been our answer here for number 12. Questions on 6, 11, and 12, rationalizing the two-term radical denominator. Any questions? All right, let's turn over to page 294 now. Let's take a look at 13 through 16. Very quick rationalizations here. Since we're working with monomials, number 13, we have 3x over 5 times the square root of x. Now, this isn't a two-term denominator, so I don't need to multiply by the conjugate. What would I need to multiply by to rationalize the square root of x, Maddie? I'm sorry? So if I just multiply by an x, good, by the square root of x. That way in the numerator I end up with, good, 3x square root of x. Again, these two don't mix, but here I end up with 5 times the square root of x squared. I don't mind if you think this in your head and realize, but the square root of x squared, class, is x. I don't mind if you do that step mentally. Hey, this is going to be 5 times the square root of x squared. That's going to give me an x. But we wouldn't want to leave our answer like this, Maddie, because we can to get where we should specify that x cannot equal, class, 0, because we canceled something from the denominator. How many ended up with 3 times the square root of x all over 5? Whether or not you remember to specify x can't equal 0, small detail. But how many got this far? How many got this far, just didn't think to cancel the x's? Questions? All right, let's take a look at number 14. We have 5 over 2 times the square root of 2. Noah, what do we need to do? Multiply by square root of 2 over square root of 2, or top and bottom by square root of 2, we might say, giving us. Good. In the denominator, this is a square root of 4, which is 2, times this 2 gives me 4. Again, I don't mind you doing that in your head, of course, in the numerator. And nothing cancels. We're done. How many had this answer on number 14? All right, that's encouraging. Let's take a look at number 15. Now here, they didn't separate it into numerator, denominator. The whole fraction is just stuck here under the radical. So this is more like what we saw earlier. What would I need to do here, Brecken? I'm sorry, louder. What do I want my denominator to be, Brecken? Something that's a cube, right? So is 4 a cube? No, it's a great square, but it's not. It's a horrible cube. What would be a good cube? What are our cubes? 1 cubed is 1. That's no help, right? What's 2 cubed? 8. Would that help? Oh, it would. Now, if it didn't, we'd say, what's 3 cubed? 27. That wouldn't help. What's 4 cubed? Hey, that one could work also, but I'm lazy. I like little numbers, right? So I'm going to go for an 8 right here. Can I take the cube root of x? No, but I can take the cube root of x cubed. All right, so keep in mind, what's the goal? What could I get this to become? Now, how do I get there? Could multiply by, underneath the radical, of course, a 2x squared. Technically, it's the cube root of 2x squared, but because it's still under the radical, we just think 2x squared top and bottom, right? So the numerator also changes. All right, now what? All right. There we go. We're going to keep the cube root of 6x squared, but of course in the denominator we get the 2x, and we have that answer for number 15. Okay, only the person who's exempt. For those of you who are going to be taking the exam, questions? All right, let's take a look at number 16. We have the cube root of 1/5. 4th. And Noah, let's come back to you. Thoughts? And multiply by 2 under the radical order. So technically it's a cube root of 2. And of course, what would you do to the bottom? So really I'm just rewriting the fraction. Instead of 1/4, I'm going to rewrite it as 2/8. And my answer becomes 2. Where? On the bottom. What in the top? 2. Cube root of 2. Okay, we're moving very slowly today. All right, which is unfortunate since that means we're not going to get to as much review today. All right, well, let's give you a chance to redeem yourselves as we've been shaking off the rust from the weekend. The problem is you've been studying so hard for all your other exams that your mind is overwhelmed at the moment, right? That's what it is. It's not that you waited till this morning to do your algebra homework. At your seats, rationalize these denominators. for sake of time, pencils down, take a look at these, see how you did. We should have finished the first one easily. 5 squared root of 2 over 2, everyone good? On the next one, multiply top and bottom by the cube root of 3x squared, so we get a 27x cubed, which gives us 3x. Of course, that means we have a 3x cube root of 3x squared in the top. The 3's cancel, the x's cancel. All we're left with is the cube root of 3x squared. Of course, x can't equal 0. And there's our answer. We're good to go on that one. Other than maybe the x can't equal 0. Okay, good. All right. On the next one, multiplying top and bottom by 4 squared root of 2 plus 5. In the denominator first, that's a 16 times 2 when you square the first. That's a 25 when you square the last. Of course, we'll subtract the 32 minus 25. You get 7. In the top, you're just distributing 12 squared root of 4, which is 12 times 2, which is 24, and 15 squared root of 2. So 24 plus 15 squared root of 2 over 7. Good on the third one. Question, comment? All right, and on the last one, multiply top and bottom. I don't know where my brain was momentarily. I started to write 2 squared root of 5 minus square root of 3. And I'm like, whoa, whoa, whoa. Top and bottom by the conjugate of the denominator. Now, the reason I wanted to mention that is I've seen students do that as well, unfortunately, in quizzes and tests, right? And start with the denominator. Write out the conjugate, then just make sure you do the same thing in the numerator. So we square the first to get 9 times 5, square the last to get 4 times 3. That's 45 minus 12 or 33. And on the top you FOIL. 6 squared root of 25 or 6 times 5 or 30. Negative 4 squared root of 15. Positive 3 squared root of 15. Negative 2 squared root of 9 or negative 2 times 3 or negative 6. Come out, you get 24, negative square root of 15 all over 33. How many on the right track at least on that last one, even if you didn't finish? Questions on the last one? Questions on this at all? All right, put your books away, just have out some paper. Let's begin reviewing specifically for your exam now. One section on the exam will be basic algebraic representation, stuff we've been doing really since the very first test of the year. I'm going to dictate several questions to you. You write out algebraically how we would represent these statements. How would we represent 6 less than 4 times a number? 6 less than 4 times a number. Number 2, how would we write the product of A and C? The product of A and C. Number 3, how would we write 3 more than twice B? 3 more than twice B. Number 4, the sum of twice X and 3 times Y. The sum of twice X and 3 times Y. Number 5, 5 increased by the square of A. 5 increased by the square of A. Let's suppose that Maddie had $M and in an attempt to buy off her math teacher, forgetting she didn't have to take the exam, she gave the math teacher X dollars. How much money does Maddie have left? Maddie has $M, but gives X of them to her math teacher. Just kidding, it wasn't to try to buy him off. It was just to show her appreciation for all his hard work in teaching her this year. She gives math teacher X dollars. How much money does Maddie have left? Number 7, let's suppose that Noah has N pairs of basketball shoes and Brecken has B pairs of basketball shoes. Together, how many pairs of basketball shoes do they have? If Noah has N pairs of basketball shoes, Brecken has B. Together, how many pairs of basketball shoes? Let's suppose that my son Timothy is X years old. How old is he going to be in 25 years? Suppose my son Timothy is X years old. How old is he going to be in 25 years? I don't want to think about that because that means I'll also be 25 years old. I'll be a hunched over old man. How old is Timmy going to be in 25 years? Let's suppose my daughter Chloe is A years old. How old will Chloe, or how old was Chloe 5 years ago? Suppose Chloe is A years old. How old was Chloe 5 years ago? let's suppose Maddie is Y years old, and let's just say, I don't think this is true, but let's suppose Glenn is 4 years younger. How old is Glenn? How old is Glenn if he's 4 years younger than Maddie? And let's go with a fictitious, no, let's not. Let's go with Gavin. Let's suppose Gavin is G years old, and let's suppose his sister is 6 years older. How old is Gavin's sister? If he is G years old and his sister is 6 years older, how old is his sister? All right, let's take a look at these answers together. Number 1, we should have had 4n minus 6. Number 2, we should have had AC. Well, by the way, number 1, you could have had any letter there. 4x minus 6, 4z minus 6, whatever. Okay, number 2 was AC. Number 3 should be 2b plus 3. 2b plus 3. Number 4, 2x plus 3y. 2x plus 3y. Number 5 should be 5 plus a squared. 5 plus a squared. Number 6 should be m minus x. M minus x. Number 7 should be n plus b, or b plus n. N plus b, or b plus n. Number 8 should be x plus 25. X plus 25. Number 9 should be a minus 5. A minus 5. Number 10 should be y minus 4. Y minus 4. And for number 11, g plus 6. G plus 6. Were we perfect on algebraic representation? All right, we've been using it all year. We should be good to go there. All right, we don't have a lot more time. So you know what I'm going to do? I'm going to give you homework. So you need to copy these problems onto your own paper. Just write the problems down and we'll take a look at them tomorrow. 28 divided by 4 plus 3 times the quantity 6 plus 1, negative 12. Copy that one down, and then copy down these others as well. Give you 4 short homework problems. Solving using order of operations. We'll take a look at these tomorrow as we continue our exam review. Actually, I do still have 1 more minute. You know what? I'm going to give you even more homework. I'm going to give you the other thing we were going to do in class and didn't have time to do. All right, so next set of problems here. Write this down. If x is 3, y is negative 2, and z is 4, find the value of 3x minus yz, 2x cubed minus y squared plus z, xyz, and xz over y. So 8 homework problems. And we will take a look at those in our next lesson. All right, have a wonderful rest of your day once you got those copied down, and we will continue reviewing tomorrow.